Welcome, I'm Renan Santana, a developer, and my teammate Olena Tukchenko, a developer. Our product owner is Ali, and our instructor is Masood Sajadi. And our project is called UrbanDecisionTheater. Problem definition. Urban city planners need to solve complicated flooding scenarios due to sea level rise. And the types of problems when facing persistent flooding or recurring floods are heavy traffic, health issues, like stale water can cause a mosquito outbreak, saltwater intrusion, which means that seawater enters into freshwater aquifers, sewer overflow, population emotion, which means how stable is the city. And finally, the most important problem is a less than optimal layout decision of the placement of pumps and sewer systems can cause millions of dollars to be wasted while still having the underlying problem. So here's the current system. Typically, urban planners rely on regional height data gathered from the satellite and geological terrain types. However, there are many unknowns that change over time, such as the permeability of the terrain. The limitations to the system include time constraints on planning and building, budget evaluation, team organization, site evaluation, and other details for large-scale project execution. Here's the project management Gantt chart. Here you can see how we distributed our work through the entire semester. We broke the chart into two tables to be able to see the dates and other. This chart only shows the user stories that were completed and the final documentation. Here are the user stories that were implemented. Select starting budget, start menu, begin button, create pump water removal system, create navigation, enable Oculus, display budget, display gain time, create sea level manager, create urban city selectors, consume path, store decisions, add traffic intensity, produce path, display traffic, create viewer perspectives, add traffic time of day, create budget pump transactions. Here is the use case diagram. In the system, we have two types of users. The moderator is a user that will have a separate scene or view, which the moderator will be able to monitor the decisions made by the decision maker. The second user is called the decision maker, which he is considered to be a urban city planner. So this user will be in the simulation making decisions. Here is a use case called display traffic. I will only go over the user story, actors, and precondition. The description is better described in the sequence diagram. So here's the user story description. As a decision maker, I would like to be able to view the traffic as a grid so that I'm aware of the amount of traffic happening in the urban city. Actors in play here is the decision maker. The preconditions are the moderator clicks the begin button in the start menu. The display traffic script invokes the start function. The texture and color objects are created. The asynchronous timer is created and assigned to the onTimed event function. The initial draw of the image is called, and the color is assigned to the texture. The asynchronous timer is invoked to start. Here is the sequence diagram for display traffic. First, we have the decision maker, which presses the control key in the simulation scene, which then has a on press to the mono behavior, which it will be called on a new frame update on display traffic class. If the key is control, we display the panel. We have a timer class, which is considered as a thread, and it will be called once the timer elapses. Once it does elapse, it calls the onTimed event function, which will then go through a for each loop on the road set, calculating the color intensity of a particular node, which will then go to an isUpdate to true, and then we'll go back to the main thread execution and test if isUpdate is true, in which we'll apply the new texture and set it to the image. We then and finally say that isUpdate is false. Here is a use case called Create Urban City Sector. I'll do the same process of describing the use case as I did in the previous one. User story description. As a moderator, I would like to have the city to be divided into sectors or blocks so that data such as traffic, water height, and population emotions can be gathered for the individual sectors. The type of actors in play here is the moderator. Preconditions here, the moderator is on the start menu scene. Okay, here is the sequence diagram for create urban city sectors. The moderator clicks the begin button, which has a onClick UI function leading to the model behavior awake function of the grid class. The first two steps is initialization of the attributes, such as grid size X and grid size Y. Next is the initialization of the sector names, which checks the sectors that are selected from the editor. After we loop X and Y, we create a node which will also check if it is a sector. Then we cast a ray which will detect if the ray hits a road sector. This modifies the attribute that makes it a road node. Then we cast another ray which will detect if it is a sector of a city block. The purpose of this if-else is to set the beginning of the city block sector and set the last point of the city block sector. Thus, at the end of this, we have the scope of each city block and set which node is a road node. Here is the city decomposition. We used a model view controller approach and a client server. The model contains three subsystems. The first is entities in the game, which are called game objects. The other two subsystems are client services that are needed to communicate to the server. The view contains the scenes of the application. The controller contains the scripts that manipulate game objects and process user input. The server houses the services, which are the communication piece that respond to the client. Here is the system deployment. In the image, we have two instances of our application running and a server in the middle. Here are the hardware and software requirements as well. The hardware, we have PC, Oculus with the latest version. Software requirements, we have a Linux-based server, Unity version 5.3, a Windows 10 version, and Visual Studio 2016 is optional. Here is the persistent data. We transfer completed simulation files after the simulation is over. Here is the security. We are using a internet relay chat, which only send a one-way defined decision chat to the moderator. The MongoDB service will be encrypted. Here is the minimum class diagram. The thing to note here is that classes that inherit model behavior will usually have an update, which is called an every frame update, and a start function. The black color in here indicates system classes. The design pattern used here is called singleton, since majority of the classes will only have one instance when application is running. Here is a state machine of display traffic use case. So if there is a key input and it's correct, we display the panel. When we release the key, we hide the panel. We also have a timer which will elapse, leading to the texture state of update, and then apply this texture state. Here we have only one of the main algorithms used in the system. This one is called display traffic. So the first method is called update, which is called within every frame. We check if the input is correct, which has to be a control key. If so, display the panel. else we hide the panel. We also check if isUpdated is true, then we update the image texture and set isUpdate to false. In parallel or asynchronously, we have a onTime event function being called when the timer elapses. We thus go through a loop going through all road nodes, updating its color intensity. Then we set isUpdate to true. Here is a representation of the main algorithm as a visual. Here is a test case of create urban city sectors, sunny. The purpose is to ensure that the city is divided into a road, a city block, or if it's none of these, it will be an NA sector. The precondition is that the moderator click the begin button in the start menu. The input is the left click on the begin button from the mouse. The expected output is that each sector will have a set of nodes that represents the city. Here is a test case of the rainy version. The purpose is to ensure that the city is divided into road, city block, and a NA sector. The precondition is the moderator clicks the begin button in the start menu. The input is the left click on the begin button from the mouse. The expected output, the road may not be properly configured, resulting in selecting the smaller piece of the disjoint set of roads. Now I will demonstrate a short demo. After you have built and compiled, you will get a executable, which will first be shown this. So here is the start menu. You are able to select the budget. This is the moderator's job. The min is 20 million and the max is 160 million. Let's demonstrate with 20. So we then press the begin button, which loads the simulation scene. On the top left, we have the pump, which will spawn a pump-like structure. You'll place it by clicking again. You are able to move with your arrow keys. You also have the ability to use the scroll wheel to move up and down the city, like this. On the top center, you have the game time and the date. On the right, you have your budget. And as you saw, when I placed the pump cost 5 million, which decreased the 20 to 15 million. We also have another function which, by holding down Shift B, brings the top view of the city. And leaving this is the same way as coming in, Shift B. We also have another function in which you can hold down either the left control or the right control, which will display the traffic. The traffic is affected by the time of day. So in the morning, traffic is medium type, or sometimes rush hour. In the afternoon, around 3 to 4, 5, 6, it is a little bit heavy traffic, and it starts to die down. Between 12 and 6 a.m., the traffic will be very minimal. And then it will start the whole cycle again, and being 7 o'clock, 7 a.m. to 9 or 8 a.m. in which the traffic will start to increase, and it will also increase from 3 to 5 and start the cycle again. Also, in which you're not interacting, but it's happening, is sea level begins to rise and fall according to the time. And this was all modeled from a real data gathered from the NOAA. Let me give you a tour of the city. So while I'm cruising around here, this area was all modeled from a height map gathered from terrain.party website, which was then converted into making it have a height to it. So you can see, or you can try to find, this geological point here on the map from Google Maps. So if you can find near Miami Beach this little canal-like structure, then you'll know for sure that I did get this height data and it is correct. And this has been my demo. I hope you enjoyed. Thank you for watching.